This is an explanation video of Newton's and Derek's third law. Derek says larger objects apply larger forces to smaller objects. Newton says for every force there's an equal and opposite force. So first we're going to look at this example of the car crash. Big truck hits small car. Small car goes flying. Big truck doesn't move that much. Again, small car hits big truck. Small car goes flying. Big truck moves a little bit. So it seems that Derek is correct after this, that larger forces apply larger, that larger objects apply larger forces to smaller objects, but all you have to do to make that statement correct is replace larger objects apply larger accelerations to smaller objects. So, and we can see that up here. If you have 10 newtons, you can throw a 2 kilogram ball at 5 meters per second squared, or a 5 kilogram ball at 2 meters per second squared. And that's basically what happens in the car example. The heavier ball is like the truck, the smaller ball is like the car. So they both have 10 newtons being exerted on them at the crash point. The only difference is, since the truck is heavier, it has less of an acceleration. So this kind of just rounds it off here. This trampoline example, again, I've isolated the trampoline, so the only forces here are in relation to the person, just to make it simpler. But the person, there's the force of gravity acting upon it always, but there's this neutral force. As soon as he hits it, there's a neutral force from trampoline to person. And that's down, and that's what pushes him back up. However, there's also a neutral force from the person to the trampoline. And we know that because the trampoline does compress. There's a force being exerted down. There's also a force being exerted up on the person. So with that, we can prove that it's not just the one. For every, as he says, for every force, there's an equal but opposite force. Both these forces are the exact same, they're just in the opposite direction. So this one's facing down, this one's facing up. So that's an explanation of Newton's third law.